All right, 5.8 is what we finally come to. We have learned all the different parts of the factoring. We have then put it together in 5.6, or like this is how the whole thing looks, or the big picture there. And then 5.7 we start solving equations. So just to reiterate, why is factoring such an important concept is because if you think back to chapter 2, we're only able to solve for x when it's a linear equation. If I give you 2x plus 3 equals 0, we're able to solve those kind of equations. But we live in the three-dimensional world, and not everything is linear. Right? We have things going up, going down, we have curves. So we have to go up to a quadratic equation. We got x squared with stuff. Well, we still have to break it down into its linear forms. And that's why factoring is such a crucial thing. We're able to take x squared plus 3x plus 5. We're able to break it down into its linear parts, and if we're able to break it down into its linear parts, then we're able to solve it. That's kind of the power behind factoring. All right, but with 5.8, well, now we're going to talk about applications of this stuff here. So, I hate to say word problems because it gets all people scary. I'll just say applications. All right, this section actually did a pretty good job of sort of giving you a step process. I thought, wow, that's actually a neat way to do it. You define your variable first, and once you define your variable, then you're going to define anything else in regards to that variable. Okay, that's x, then the other thing has to be x plus 7. Once you define your two variables, then you figure out, draw a diagram or whatever you want to do to give you a sense of what's going to be like. And then at that point, then can you get to the equation? If you can get to the equation, good. Then you do the techniques from chapter 5 to solve it. Okay, so we're going to do that step process. All right, diagrams sometimes. If it's a geometry question, yes. It's an algebra question, we'll just skip to go to number 4 right away. All right, but let's go for it. We're going to start off pretty easy, and we're going to get sort of more and more complicated as we go. So first, something called the algebra questions, or the number questions. I think that's the way they're called, number questions. Number problems. Just had to look it up just to make sure. Okay, so let's go for it. The product of two consecutive odd integers is 35. Now, we talked about odd integers before, is that right? Yeah. If first one is x, then the other one has to be x plus 2, right? Because their numbers are made of even and odd, even and odd, even and odd. Okay, so let's go for it here. So I'm just going to say x is just an odd integer. You can say the first odd integer. It doesn't really matter what you say here. You're going to just label that one as the odd integer. All right, so the product of two consecutive odd integers. So if the first one's x, the next one has to be x plus 2. X plus 2, that has to be the next odd integer or the second odd integer, just depending how you want to write it. All right, step 3 we're going to skip because we really don't need to draw a rectangle. There's no square to draw, so go directly to step 4. Can you put this into an equation? Yeah, the product. Product means we're multiplying, so I might as well do this right here real quick. The product of two consecutive odd integers, perfect. That's going to be x over here. The next one has to be the x plus 2, is 35. I think I like that. And then we solve, and this you should already know, because of course you finished up your homework for 5.7, right? Maybe. Okay, let's go for it. So, you can't factor stuff down if they're not equal to 0. You got to make it equal to 0. So in this case, we got to multiply the x's together, sort of like a distributive property here. Why did I rewrite it? I have no idea. So distributing the x to the x, distribute the x to the 2, and now at this point subtract 35 to bring it over. I'm going to run a room here on most of these slides here. Oh, what did I do? Yeah. So I was just wondering, well, what did I do here? I just dropped the parentheses here, because if it's a monomial, it doesn't really need parentheses on it. But either or, you could have just started foiling from here. All right, let me rewrite what I got at the end here. And factor and solve, all yours to finish it up. All right, two numbers multiply negative 35, add to a positive 2. Positive 7, right? Negative 5, is that right? Kind of careful on the signs there, just to make sure the signs are correct, because you are having a negative 35 there. So set each of them equal to 0. That was called the zero factor property from the last section. So subtracting 7 on one side, adding 5 on the other. Got ourselves the two answers. Okay, let's kind of real quickly before we finish off the problem, let me go back to it. So notice what it says: the product of two consecutive odd integers is 35. Do we know the answers already? Yes. What are they? Or what is the, say again? 7 and 5, right? Or 5 and 7 if you want to go from directional. So it seems like, Mr. H, why did we do all this work? It's because we just figured out that 5 is the answer. But how about this one? Negative 7. What's the next odd integer after negative 7? Or bigger than negative 7? Negative 5, huh? Right? Because the negative sign, negative numbers sort of go opposite direction. So negative 7 times negative 5, would that be a 35? Oh, cool. Okay, so there was some other numbers here that would work. So I'm just checking real quickly here. Negative 7 plus 2, will that fit? Hey, that is true. Those do work. So by setting up the equation, we found an answer that we would have not found before if we were just sort of guessing. Okay, now the only thing is, if this is a word problem, we have to actually answer it in a word fashion. So we have to sort of set up an English sentence to give me the answers. Now, so I want the numbers, and if there's any units, then the units need to be included. Cool. So I put something like this here. The numbers, since we're looking for numbers, the question is find the integers, or you can say the integers. So the integers are negative 7 and negative 5, and 5 and 7, right? Because there's two sets of numbers here. Maybe the integers are negative 7 and negative 5, as well as 5 and 7. Yeah, so you got to put both sets. Yep, absolutely. So what are the integers? Negative 7, negative 5 is one set of integers, and 5 and 7 is another. Okay. The next number problem is a little bit different, so we should talk about it here. It says the sum of two numbers is 15. Their product is 54. So again, the number answers are probably going to be so easy you can guess them. But it's the whole point of can I just sort of do this process here. So real quick here, this little part right here, the sum of two numbers is 15. We're going to talk about that. Or sometimes you'll say the total is, and I'll give you a number for the total. Because notice you got two operations here. I'm adding on one sentence, and then I'm multiplying on the other. Like, ooh, that's too much operations right now. Okay, so here's what we're going to do. If you want to think with me on this one and not write it down, that's okay too. So I'm going to make three columns here. So first number, second number, and total. That's what I need. Let's talk about this before we actually do the problem. So if you want to get out maybe an extra sheet of paper a little bit or off to the side, we've got to do some conversations here. Okay, so if I say there's two numbers and they add up to 15. So underneath the total, I'm going to have 15. But let's sort of work this out, see if this makes sense. Okay, so let's say the first number was 10. Anybody, what would be the second number? 5. Yeah, it's the part that's sort of missing, is that right? How did you get the 5 technically? I think you should have done 15 subtract 10 is 5, right? The grand total subtract what I have already is the leftover of 5. Okay, so a little bit more trickier here. I'm going to make you do the work now. 9.8 is the first number. What does the second number have to be for the total to be 15? 5.2. Oh, you're cool. Did that in your head. Yeah. So you technically would be doing this, right? You'd be subtracting for 15, 4, 10, 2, and then 14 minus 9 is 5, 5. But notice we're subtracting. We're subtracting total. We're taking the total, subtract the first number. So here's the next step that we got to think about. Okay, so real quick here, if the first number, I don't know what the first number is, so I'm going to label, if this is x, what would have to be in the second column? Say again? Cool. Good. So let me go over here. Let's see if this makes sense here. How do we get the 5 again? It was 15, right? Subtract 10, right? Get in there. How do we get the 5.2? It was 15 subtract 9.8. So over here would be
15 minus 6.
Hey, look at that. Everybody answered all right. It's 15 minus x. So if you add those together, the x's will cancel off, and then you get yourself the total of 15. Okay, so we need that in order to do this here. So the first number is x. And if I know that the sum of the two numbers is 15, that means the second number has to be 15 minus x. Okay, everybody good there? That's how we set up the variables. All right, now let's see, their product is 54. I think you guys know what to put from there. We do that question 1. Their product is 54. And now it's going to be very similar to the first number we did. All right, distributing the x. And let's see, to factor I got to move the 54 over. So move the 54 over. So minus 54, set equal to 0. Alright, and I don't like the order here. Shouldn't the x squared go first if I'm going to be factoring? So let's put the negative x squared first, then the 15x, then the minus 54. And then we got ourselves another problem. Because we do not factor with a negative in front of our x squared. So how do I get rid of that negative? Multiply, how about multiplying both sides, right? Let's multiply both sides by -1. Would that do it? Okay, so you can only do this with equations here. Couldn't do it if there's no equal sign here. But because there's an equal sign, I can multiply. Let me rewrite it over here. I can multiply both sides by -1. Or I can factor out a -1. one, whichever way you want to think about doing it. I don't like the way. You can factor out the negative one. I think I was just trying to show you can factor out the negative one. You can multiply through by negative one. And you can divide through by negative one. It doesn't matter any which way you do it, but I'm going to do it by multiplying here. So multiply this side by negative 1, multiply this side by negative 1. So how about x squared minus 15x plus 54? Alright, I think I'm set up for factoring. Only way to get an x squared is x times x. Only way to get a positive 54, but you add it together to give you negative 15. Sorry. Alright, negative 6 and a negative 9, is that right? Alright, again, zero product property says the zero factor property, depending which textbook you have. Alright, and again, got this little situation here. There are two solutions, comma, 9 and 6. So if x is 9, the other number is 6. If x is equal to 6, the other number is 9. We good? Just depending which order the numbers will be. Cool, good. Let's jump to the geometry questions. Yeah, so now geometry problems here. Alright, the length of a rectangle is 1 more than twice the width. Okay, the area is 21 square inches. Find the dimensions of the rectangle. So let's go for it. So x has to equal something. And I'm going to say x is equal to the width. And the reason why I say that is because on a rectangle you always have a length and a width. The width is always smaller. So I'd rather work with like multiplication as opposed to division. I'd rather work with addition as opposed to subtraction. So I'm always going to get a bigger number. Alright, if that is the case, that means, let's see, the length of a rectangle is 1 more than twice the width. 1 more than works backwards, huh? So 1 more than twice, isn't that right there? It's 1 more than twice, and that would be then having to be the length. Plus, notice whenever you read the first sentence, the length is an equation in reference to the width. Right? So the length is this based upon the width. So then you know you want to start off with the width and then formulate the length equation. Alright, with that said, there's my little box, my little rectangle. And whether it's area or perimeter, there's my length and width. And this time it's area. You're always going to put area or perimeter inside the box. Just customary. So If it's perimeter, you're going to put P equals. Since we're talking about area, A is equal to. Alright, for these geometry questions, then you need to go back to geometry and figure out, okay, what's the formula for that? Formula for, looks like the area. Perfect, you got it. So area is length times width, or width times length, it doesn't matter. There's my geometry formula. If you want to put the units in for the area, that's fine. Some inch squared, that's fine. Alright, now let's put in everything we know. Do we know A? So 21. Do we know L? Perfect. Yep, 2x plus 1, and then the width is x. Alright, give you guys a little time to try it yourself to finish up. Alright, let me go for it here. See, most or some people done here already. So distributing the x gives you 2x squared. Distributing the x again gives you the x. And let's move this 21 over here. So how about 0 equal to 2x squared plus x minus 21. Alright, the factoring here, it's a little more complicated one. Plus, you know what? I don't like the 0 being in front. If you're okay with it, that's fine. But you can always move the 0 around. So you can actually even do like this. Just swap the two equations here. It's kind of the same thing as 5 is equal to 5, and then you swap them and you say 5 is equal to 5. Still the same thing. Okay, so let's see. The only way you can get a 2x squared is a 2x times x, and the only way you get a negative 21 is a 7 and 2, but I need to somehow make a positive 1 right here. So this is the way I think about it. Let's see if this will help here. I have a 7 and 3 possible factor, or 21 and 1. First of all, I'm going to try the 7 and 3 first before I try the 21 and the 1. And so I'm thinking to myself, you know, this number here is going to be multiplying over here, right? So I'm going to actually still get a multiplier of 2 over here. So I'm either going to be multiplying the 7 or the 3 of the factors, right? So hold on though, but 2 times 3 is 6. So that's 6. That means I can subtract 1 from the other, and I'm good. So that means I need a minus 3 here to give me a negative 6. Then I need a plus 7 over here. That makes the negative 21, as well as gets me the middles. Okay, we're good there with that sort of thought process? Just multiplication. Alright, and I think you guys are done anyways here, so let me rewrite it. 0 factor property. Set each of them equal to 0. And subtract 7, divide by 2. I get negative 7 halves. And how about the other side is a 3. Alright, what should we do next? Whatever we're going to do, we're not going to tell Mr. H. I understand. Okay, fine. Now, we're going to say, does any of these answers make sense? Does negative 7 halves make sense? No, because you can't have a width, because that's what x equals, right? You can't have a width that's negative 7 halves inches. That doesn't make sense. So, can't have any negative values for distance. X equals 3, that makes a lot of sense here. So here it is, and if you want to, you can even check. Just go back to the original equation we set up, and it works. That's cool. Alright, so here we go. How about, real quick before we even start the sentence here, what is the question, or what are the directions? What do we need to find? Question number 3, it says find the dimensions of the rectangle. Okay, so now they want length and width. Good there, so let's go for it here. So the width is 3 inches and the length is 7 inches. So notice, sentence, it gives me what the variable was, or listed as, gives me the number and gives me the units. That's kind of the best way to answer those. Okay, good there. Let's jump to the next one here, number 4. And I want to see if you guys can try it yourself here. Go for it. So the numerical value of the area of a square is 3 times its perimeter. What is the length of it? I'm going to just stop, just see how far you guys can get here. Give you a few minutes or so, just trying it yourself. Let's go for it here. So first of all, what is x going to be? X is just the side of a square. Good there so far. Hopefully you made this square. Label the square because both the length and width are the same. Alright, then over here it does tell you what it is here. The numerical value of the area of the square is 3 times its perimeter. So let's go for the area of the square is 3 times the perimeter. Okay, now let's see what can we know from geometry here. So how do you get area of a square? Say again? How about second? Is that good? Because it's just length times width. But since they're both the same, then you get x times x equal to, and I got my 3 over here. Perimeter. What's the perimeter of this particular square? The perimeter is the fence around the square. Well, you got x over here, is that right? X, there's one x, there's another x, and another x. Everybody good there? So it's 4 times x. Alright, multiplying the 3 and the 4, how about a 12? X. Subtracting the 12x out. And what should we do the factoring? What are we doing here? Greatest common factor, right? That's the first step of factoring, and it is x. Leftovers will be x minus 12. Split them off, so that means the x has to equal 0, or x minus 12 equals 0, and then with that here, the first one's solved, the second one is not. So how about adding 12 to both sides, and how about we get ourselves x equals 0. Alright, anybody, what do you think the next step should be? Looking at this here, does this make sense that we're going to do this? You can't have a distance of 0, a length of 0, a width of 0. So you can't have negative distance, but you really can't have 0 distance either, or else you don't have a square. You don't have any figure whatsoever. So the way we say this is that any distance or length has to be non-negative, which means can't be negative. Sorry, it has to be positive. It has to be a positive number. Yeah, it has to be a positive number. Because 0 is considered neutral, not considered positive. Okay, cool. There's that. Just kind of verifying just to make sure if this makes sense. Does that make sense? The square, there's my side, is 12. If I square it gives me 144. On this side here, 4 times 12 is 48. 48 times 3 is 144. So we've met the condition. The condition would be that x has to be equal to 12. Alright, English sentence. Let's go for it. Side of the square is... Now the funny thing is in this problem, there is no units, right? There's no inches, there's no nothing. There's just values here. So what we do is we just write units. Whatever the units will be, that's what the units will be. Okay, and number 5. Before we get to number 5, gotta talk a little bit about this situation here. I think you already know it here. Something called the Pythagorean theorem. Seen this before? How many have never, ever seen this before? Okay, Pythagorean theorem just says if you have a right triangle, and right triangle means that one of the angles is exactly 90 degrees. You either write down the 90 over here, or what you do is you make this little box like this, just kind of box straight up, come down, and that signifies 90 degrees. You don't need to do both. I just kind of put both. So either 90 degrees in there or the box. And then we have this relationship that if the hypotenuse squared is equal to the sum of each of the legs squared. That's kind of what we have there. I think we know that already here. We're going to use that one. So we're going to jump to this. The hypotenuse of a right triangle is 13 meters. One of the legs is 7 meters longer than the other. Find the lengths of the two legs. And again, I'm going to have you try this yourself. Just get as far as you can. So label the x. X would be maybe length of one of the legs. Alright, let me start as well here. Again, looking up here just to see if you have something. It doesn't have to be exactly the same, but comparable here. So x is going to be length of a leg. And means that the other side has to be the length of another leg would be x plus 7. Those are the two legs. We do have a geometry problem in our hands, so might as well make a diagram. Pull box right here in for the 90-degree angle. Same as this one has to be the hypotenuse, because the 90-degree has to sort of be opposite hypotenuse here. So let's pull in everything, put in everything we know. That's going to be x. This one has to be x plus 7. The other one then has to be 13. I'm going to rewrite it the way the formula was written here. Formula was written as c squared plus a is equal to a squared plus b squared. 13 comes in for c, x goes in for a, and x plus 7 for the b. Alright, 13 is 169. X squared is just x squared. And this one, maybe off to the side somewhere, just FOIL out x plus 7 times another x plus 7. See what we get. Or you may know the quick way to do it. Remember the quick way to do it? This is a binomial being squared. Take the first term, you square it. Plus sign comes down. And remember how it sort of is going to double in the middle, right? So it's x times 7, 7x, and it's going to double that. So how about 14x? Those are the factored forms, special factored forms. And then take the 7 there at the end and square that one, and you can get ourselves a 49. Okay, now let's gather together like terms here. The only ones are x squared and x squared make a 2x squared. So 2x squared plus 14, x plus 49. Alright, let's see, I'm going to move the 169 over, so it said equal to 0, so then I can start. So I can start working with this here. Alright, let me rewrite the problem here. Next slide, but let me rewrite the problem. That's what I had last time. There it is. I'm going to leave the 0 as is. You can switch it around if you like. You put the 0 on this side if you like. But that's fine too. Factoring. What should I do first step? 2x gets to go out. Is that right? Or just a 2? Just a 2. Because there's no x all the way at the end here. Question is, why only take out the 2? What other number would you like for me to take out? So I know they're all even, right? So I know at least 2 is going to go. But 2 is already here, so 2 gets to go out, and then there's no x in all 3 terms, so you can't take out the x. All right, let's go with it here. Remember how we said 2 is equal to 0, or you can have the rest equal to 0? And remember, this one's just going to go away, because that's, you can either write the reason why it's going to go away. Some people, they just kind of drop the 2 off completely, just kind of goes away, and then you're dealing with this problem here too. All right, 2 numbers, multiply to negative 60, add to a positive 7.
I
think 5 and 12 might do it. Yeah, that's right, because the difference between them is 7. So just get the signs right. That means we want the biggest one to be positive and the smallest number to be negative, because therefore we have to have a positive 7. All right, 0 factor property there, and solve. Again, x is a length, is that right? Yeah, negative 12 does not work. Cancel that one out. So then, sentence in English. The length of, I guess we need to know the question here. Let me get back to the question here. I think he's asking for final length of the sides here. Find the lengths of the 2 legs. Cool. All right. So the lengths of the legs are 5 inches or 5 meters and 12 meters. All right. So notice it's this 5 plugging back into our problem here. So we go back to the diagram. So if that's 5, then this has to be 5 plus 7 or 12. Okay, one little extra thing I want to mention here. I keep on saying that we can't have negative distance, right? Or negative for length or negative width. But if this right here, if this was the case, and I'm going to add a little extra here. Let's say that this was a plus 10. Good there? Say this was the setup. That means x, the x itself, x could be equal to a negative 1. Good there? X could be equal to negative 2. X could be equal to negative 3. Because it's not so much the number at the end, what the number is, it's so much what it represents. So here, easily I can go to a negative 6.99999. Those will all be fine, but I just can't get to a negative 7. So when I say x equals to negative 7, then I'm in trouble. Okay, good there? Just not so much just the fact that the answer is negative, is that let me erase it. Let's see, I didn't finish my sentence here. It's the fact that the geometrically it has to work out. It has to be positive. All right, yours, very similar to number 5. So can you go from beginning to end? All right, let me start it as well here. Again, just looking to see if you guys got it correct here. Let me give you the answer maybe. That'd be best before we start. So the lengths of the legs are 12 feet and 16 feet. How many got those correct? 12 feet and 16 feet. Okay. So let's go for it here. So again, seeing we mess up, I'm going to go kind of quickly here, and then I slow down to see if, as soon as you guys start erasing and writing, then I'll know that I need to slow down. All right. right, tell me x plus 4, and 20. So far, so good? Okay, don't see anybody racing so far. Okay. Next is putting into the formula. So I got c squared is equal to a squared plus b squared, and I got myself the 20. A is the x, and b is the x plus 4. Alright, 20 being squared is going to be 400. Squaring the x, that's the easy one. Squaring x plus 4. So again, off to the side if you need to. If you're not comfortable using the formula, then just go off to the side, go x plus 4 times another x plus 4, and FOIL it out. If you are comfortable with the formula, then it's going to be the first term squared, both terms multiplied together, and doubled. So x plus 4, so that's 4x times 2 is 8x, because the middle is double. Take the 4 and square that, gives you 16. Cool. Move the 400 over. Sorry, hold on. Sorry, simplify each of the sides first. Now move the 400 over. And 0 is equal to 2x squared plus 8x minus 384 is what I got. Cool. Wait there for a little bit here. See a few people changing some stuff. We're good? Okay. Alright, and let me rewrite it real quickly here. That's what I had before. And at this point I'm going to factor out a 2 because there's all of them have a even number. So half of 384 is 192. And the 2 again disappears if you like. You can do the zero factor property and then cancel it off so you know where it went in case you go look backwards. And this is the tough part here. Two numbers multiply to negative 192, add to a 4. 16 and a negative 12. Will that do it?
So this is where you lose me.
Okay. Okay, good, good.
Because I got all the way up until you put 2 equals 0 or, and then, because I don't know what you do.
Then we say x does not equal 0. That doesn't make sense. Then we go to this one, and then we factor this one down into x plus 16, x minus 12. Set each of those equal to 0 then. And then solve, you get x equals negative 16, x equals 12. Alright, which one does not make sense? That's gone. And so 12 is the only answer. Going back to our diagram, and sorry, let me wait a little bit here. Some people are writing stuff down. Alright, since 12 is the only answer, going back to our previous slide again, if this is 12, then this has to be 12 plus 4 or 16, so there's my two sides. So going back to the original problem, going back to the diagram, or going back to your definition of what is what. So we have to say that the lengths of the legs are 12 feet and 16 feet. There, the answer's there. All right, and then going on to two business problems here. Let's go with business applications here. All right, let's see. A company can manufacture X hundred items for a total cost of that equation there. How many items were manufactured if the total cost is $3,000? So it's sort of like a back check. You know that this is the normal equation by the time we use up the raw material, by the time we pay the employees, blah, blah, blah. So now we're sort of self-checking ourselves. And in business, this is what we think about as, sometimes we think of this as overhead. We say, okay, this is beyond what was really needed. This is something we can consider loss on a company as well. If you say this is the formula that usually produces the answer, but then this was the actual stuff, the difference between the two is the ones I can still somehow optimize here in the business here. So total cost was $3,000. but here's the equation that I know is sure. Alright, in that case, guess what we're going to do? Set equal to 0, I guess, right? I'm going to scoot everything over. So in this case, the easiest way to scoot everything over is just subtract 3,000. And I get 0 is equal to negative 1500 plus 800x minus 100x squared. Alright, first things first, I don't like the way it's written. I like the x squared to be in front and then everything else afterwards. So let's do that. Let's write the negative 100x squared in front, 800, 1500. Next, yeah, something about you can divide through by a negative 100 everywhere. For those of you that like dividing. If you want to factor out a negative 100, you're going to do this, and then you're going to get some leftovers, like x squared. So what numbers multiply negative 100 to give you positive 800? Careful there, minus 8, and then what numbers multiply negative 100 to give you negative 1500? In this case, a positive 15. Alright, in this case, again, you can split them off 2 different pieces. I'm going to just try a different way, just for let you guys see a different look on it here. We can start factoring this down. So keep the negative 100 there. I need 2 numbers, multiply 15, add to negative 8. Cool, negative 5, negative 3. So notice I have 3 factors. The negative 100 is a factor, x minus 3 is a factor, x minus 5 is a factor. We're going to split each of those off now. So let me rewrite the problem here so I have more room here. Okay, so then we're going to go negative 100 is equal to 0, yep, or x minus 3 is equal to 0, or x minus 5 is equal to 0. Alright, what are we going to do with the negative 100 equals 0? Now, and go away, cross it out, say no solution for that one if you like. Perfect. Next one is x equals 3, and the other one is x equals 5. Okay, now, we've got to go back. We have to ask ourselves, you know what? What did x represent in the first place? Yeah, it says x 100 items. So if x was 2, it would be 200 items. Since x is 3, it would be 300 items. And so the company manufactured 300 or 500 items for a cost of $3,000. So now usually the question is, Mr. H, that doesn't make sense. How could manufacturing 3 items cost the same as manufacturing 500 items? Usually does not happen, first of all. But maybe if you order more raw material, then they give you a discount on the price. And because you order raw material, then you sort of, there's that little flux there that you have. And obviously if you can produce 500, you're going to produce 500, so unless there's a market reason why you would not want to do that. Okay, and the last one. Now the last problem was about cost, and now this one's the other side is revenue. So manufacturer of small portable radios knows that the number of radios she can sell each week is related to the price of the radios. So there's a little relationship there. Where X is the number of radios and P is the price per radio. Okay, got the variables. What price should we charge for the radios to have a weekly revenue of $5,400? Alright, the revenue equation is actually given in example 8. It's just sort of like, okay, here's the revenue equation. So I'm going to write it down as well here. There it is. Revenue is equal to number that you sold and the price that you sold it at. That's it. There's your revenue. So let's see what this says. We want to know what price should she charge. So I want revenue in terms of just price. And it's kind of set up already. So revenue is $5,400. The X gets plugged in as 1,500 minus 100p times the little p all the way at the end. So notice that you see you have revenue in terms of just the price only. Alright, distribute the p at the end here. So 5,400 stays the same, and how about 1,500p minus 100p squared? Subtract 5,400 from both sides and gives me 0 is equal to, and I'm going to write the p squared first and then the p and then the constant by itself, just so. I'm getting rid of those. Again, at this point it is very similar to number 7. So I'm going to let you guys have a little bit of time trying to solve this yourself. Alright, running out of space here, so let me rewrite it here real quick. So hopefully you factored out the negative 100, and if you did that, then life became a whole bunch easier. Or if you divided through by negative 100, that would have been fine as well. So then you're really left with p squared minus 15p plus 45. At this point the factored form is p minus 6, p minus 9. Ugh, those 6 and 9, 7, 8. Alright, splitting them off into their own pieces here. Set equal to 0. And again, negative 100, no way. That is a no solution for that one. I got prices is at $6, prices at $9. And so how about this? She should charge $6 or $9 to make a revenue of 5,400. Where is this used at? Considerably. It's used at retail, considering whether we should put something on sale, right? Because the $9, that's if the shirt is new and there's a new sort of newness to it that sells the shirt. At the same time, you're trying to hit another high point by charging $6 or maybe a 30% discount. At that point, then you get the same amount of revenue as you got for it being the new shirt. Alright, so that is the end of 5.8 as we have finished off chapter 5.